All right, we are starting a new portion of our unit before what happens on Friday. What's Friday? Everybody, space bar. What is Friday?
Test.
There's a test on Friday. If you haven't heard, I might have said a couple times already, there's a test on Friday. And on Friday, there's a test. And the test will be happening on Friday. And Friday, when you show up, there's going to be a test. Okay? It will be open note just like before. But again, remember how that time felt. I know a lot of you said, Chris, I was doing great, and then I ran out of time. And it's a lot of you because you were going back and double checking and looking things up as you were going. Do everything you know first, then go back and do the things you didn't know and need to look up. Get the points that you know for sure you're going to get well first. Okay, so that is my big tip for Friday. We'll go over a little bit more of that Friday, but there's a test Friday. So ancillary question to that. What does that mean is available to you to do before the test?
Pre-test.
A pre-test. Y'all sound so annoyed by me, but I hope it's annoying and you remember it forever and you can't unhear it, okay? Do the pre-test, do the pre-test, do the pre-test. 15%. That is a letter grade and a half, okay? Difference between those who took the pre-test and those who did not. That is not a tiny number, okay? Please, 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 please do the pre-test. It was only one attempt for some reason. I fixed it to be unlimited, so you could literally do it 100 times if you wanted to. Not that you have the time to do it 100 times, but you could, okay? Any questions about test on Friday or pre-test by Friday or unlimited attempts or tutoring or anything procedural? No? Okay. Fun stuff. So our fun mole fact today is that if you had a mole of paper and stacked it to the sky, you'd be able to go to the moon and back 80 billion times. 80 billion trips to the moon. You haven't done 80 billion trips of anything, I guarantee it, right? That's crazy. Moles are so big. Okay, just driving that point home that moles are very big. Moles are very big and atoms are very small. All right. So we are going to start with the math portion of class, which I know you guys all love. So Madison. Madison, good morning.
Yes.
All right, Maddie. What do I do with every word problem in the beginning of, or what do I do with every word problem ever in any subject? What do I have to know?
Circle or underline the important information.
Right, so we have 3.41 grams of helium, but what else is important?
The atoms.
Yeah, what is it asking us for? How do we know we are done, right? We want the number of atoms. If we don't have atoms, we are not done. Thank you so much, Maddie, for playing along. Next person is Samir. Good morning. Man, you can't put that up right before lunch. That burger.
Sorry.
Good Lord. That's like cruel. There's a whole amendment about cruel and unusual punishment, dude. Come on now.
Yeah, I mean, I guess it gets people ready for lunch, you know.
I'm so ready for lunch just because of you. That aside, thank you for getting me ready for lunch. What do I do now? I know my important information. What do I do now?
Well, first thing I do is probably set up the track, like the railroad thing.
Yeah, the railroad thing. It's super annoying. So what else do I need to put here? Because we're doing our level 1 section.
So I know that the first thing that we're dealing with is the 3.41 grams of helium.
Hey, you've said it all. Good job.
And then to convert it to like atoms, on the bottom, I'm going to have to put grams so that it cancels. And so I'm going to look at the atomic mass of helium on the periodic table, 4.0026 on the bottom. And so that'd be 4.026 grams of helium. And then the way that atomic mass works is that's how much grams it would weigh if it had 1 mole of helium.
Okay.
So, yeah.
No, so if I ever need to take a day off, you're going to be the sub for the day, and we're going over moles again. That was fabulous. You literally, I'm sitting there going, what question could I ask? Nope. What question nope. So you did amazing, and I loved that. Thank you so much. So you explained everything, even where to find it, and you even explained that that's the number of grams in 1 mole in depth, which was beautiful, and I love that. Thank you so much for that wonderful explanation and your wonderful burger. All right. Janavi. Dang it. I knew it. Janavi. Okay. What do I do now?
You need to convert to atoms So you put 6.022 times 10 to the 23rd at the top and then 1 mole at the bottom.
So is it 6.022 times 10 to the 23rd unicorns?
Sorry, atoms.
Atoms of what?
Helium.
There we go. I know it's funny, but if you, like, I do that constantly, and eventually you'll be like, oh no, she's going to say the unicorn thing. No, and you'll start saying what it is. So as much as it's silly, it does have a purpose, right? So the reason we had to put the moles on the bottom is why?
Because you're not trying to find moles, you're trying to find, and you have to cancel out the moles.
Yeah, anything on top and bottom cancels. So grams of helium cancels because it's on the top and the bottom. Moles of helium cancels because it's on the top and the bottom. And I'm left with atoms of helium, which was my original question, right? This was what we were looking for. So yay. So now that I have it all set up and it's wonderful and beautiful, Esty, what do I have to use that's super, super stupid?
A calculator.
Yeah, you're like stupid. Oh, she's calculating. I love that those are now synonyms in your brain. That whole process just like made my life, right? Calculators are stupid. Never forget it. Calculators are so stupid, but we have to use them. So when I put these in, now I've had a lot of people say, can't you just use the E button on your calculator and things? Yes, if you have the calculators that do that, that's fabulous. There's also like weird stuff with the TI-30 that sometimes it'll mess up your power of 10. So if you want to be 100% sure that you're getting it right and you don't have a calculator or you have a TI-30 that does the weird like for order of operations thing, Desmos, I'm going to put it in there, is the calculator, the graphing calculator that I used when I was teaching calculus for half a minute. So Desmos is a great calculator and will always give the right thing, and you can copy and paste into it and things like that. So in terms of testing and whatnot, I will have the link available for you to do Desmos, but I just want you to know that exists. So when you're doing your homework, Desmos is a thing. Okay, Desmos is a great calculator. Okay, thumbs up. All right, thank you, Esty. So when we put this in the calculator, remember that we set these railroad tracks up because it reminds us how to put it in the calculator. So we can pretend these are parentheses. Yes. And we would put open 3.41, close, open 1 over 4.0026, close, open 6.022 times 10. And now remember, if you have to use the caret to put the exponent in parentheses, close, make sure you have the same number of parentheses open as you do closed. Make sure they match. It's a great way to check. And when I put that in the calculator, I would get the answer. I just wanted to review how to set it up again, since we do have our test on Friday. Oh no. So fun fact, Jimin, is that I started teaching 8A class last Monday. So Monday, like when 5th period showed up, I started teaching nuclear reactions and doing this lesson. And they were like, Miss, we haven't done any of this. And I literally taught for 10 minutes the wrong thing. So you are not the only one. That is totally cool. All right, I know you guys didn't see that, but like there was a whole A, B day mixed up. It was great. All right, so are there any questions on the mole thing? On the mole thing? Anything at all? Okay, so this is our topic for today. It's gonna be super great. This is just trying to get you in the mood for our lesson. So Dia, what is this?
I'm kind of dumb, so I don't know.
No, never say that. No, blasphemy. Never, 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 never. I will freak out louder than I've ever freaked out. You are not dumb. You are not dumb. Even if you feel dumb in this class, you are not dumb. You may just be a fish climbing a tree, and you are never allowed to be rude to yourself or anyone else in my room. Sorry, that was really loud. But never, never say you're dumb, okay? This is a visual pun. So it's like a joke. It's a dad joke. Okay, just to be clear. So nobody knows what this is. This is Miss Longley being stupid and ridiculous and acting stupid. I am not a stupid human. I'm acting stupid, but it's silly and fun. So why don't you give me your best guess at what you're seeing there? And never call yourself dumb. And rant.
Is it like an atom?
It has to do with the atom, right? When you did your video notes, we were talking about a certain part of the atom. So I will move to someone else. Shanmati. What do you think it is?
Is it fusion or fission?
So it has to do with fusion and fission. Yes, it's very similar. It's the same topic. Scope out a little bit. You zoomed in a little farther than my joke. Corey. So we know it has to do with fission and fusion. So what is it?
A nuclear power plant.
It's a nuclear plant, guys. Do you see it? The nucleus. Look at that. I saw all the, yes, that was amazing. Oh, I'm so happy. I visually saw you guys react to me, and it made me so happy in my dad joke space. So yes, this is a nuclear plant. We're talking about the nucleus today, which has to do with nuclear reactions, which happen at nuclear plants. Okay, fun fact, I grew up like 5 miles from a nuclear plant, and at our school, we had a nuclear plant meltdown plan where if like the nuclear reactor went nuclear, literally, we would have an evacuation plan to leave. They would take us on buses for 50 miles away from the school for our parents to pick us up. So that was cool. Fun fact about Miss Longley, living next to power plants is weird, but nuclear power is cool and safe. So nucleus, it is all about the nucleus today, and bad jokes. Bad jokes are not going to stop. That's just a constant. So nucleus. So before we talk about the nucleus specifically, I want you to talk about the different type of particles that can affect a nucleus. Particles that can be added to the nucleus, particles that can be ejected from the nucleus, okay? So we have a desmos, okay? It's a card sort. If you want to do it on your phone, you can hit that QR code. If you want to do it on your computer, I have the link in the code for you. Remember, you will not see this screen before you switch into your breakout room, because we are going to a breakout room. You're going to have 3 minutes in your breakout room, which I know is not a lot of time, but I want you guys just to kind of get talking about what each type of particle is. And that way, if you're completely lost, you're not just sitting there staring at a screen for 10 minutes. Does that make sense? So it's going to be a shorter time, but it's just kind of get you guys talking to each other, give you a break from listening to me, and get you guys your brain juices flowing for when I start asking questions, okay? So I'm going to create your breakout rooms. Dun, da, da, da. And I'm going to.
Wait, did you already put the?
Say what?
Did you put the Desmos link already in the chat?
It's not in the chat. It's showing on your screen.
Yeah.
So it's student.desmos.com and FXHANN, which is actually my middle name, guys. ANN is a very common middle name for 80s babies. And yes, I was born in the 80s and I'm ancient. We all know this. So yeah, FXHANN, okay, for our code. The breakout rooms will automatically close when ready. I am going to open all of the rooms. If you have it, go do the thing, be amazing. I will see you very soon. Okay, guys, so as you can see, when you went to the Desmos, you had 4 categories of particles. You had the alpha particle, the beta particle, the gamma ray, and the positron. So that is where we are trying to sort to. Sam or Bob. Okay, Bob, where did you start? Bob, are you here today?
Yes, the
Awesome.
Zoom was being weird. So I started with the gamma rays, or with the with the gamma rays. I put it with the largest and slowest form of radiation.
You put it as the what? This largest and slowest? Okay, so when we're talking about gamma rays, we're talking about pure energy, okay? So think about the more mass something has, the slower it moves. Think about like a big boulder you're trying to push versus skipping a rock on the water, right? The lighter one is easier to move. A gamma ray, what is happening here? A gamma ray has no mass. It is pure energy. So it moves the fastest. So it's not the largest necessarily. Which one would be the largest? Which one has the most mass? Do you remember?
Would it be alpha then?
There we go. It's alpha particle. And
Sure.
side note, thank you for saying your answer with confidence. I love that you just spoke because I guarantee you there was someone else who said the same thing because I've gotten that almost all day today. So thank you very much for being outspoken and honest. I love it. It's very helpful. Charles, what else could you put under alpha particle?
Under alpha particle, what do we already have? Okay, well, you could put the alpha symbol for one.
An alpha symbol, right? That's the Greek letter alpha. Perfect. What else?
You can be stopped by skin or paper.
Yes, it is the biggest, so it can be stopped the easiest. So it's right here, can be stopped by skin or paper. What else?
The least penetrating nuclear decay.
The least penetrating nuclear decay. Awesome, because it is the biggest. Is there anything else we can put there?
Largest and slowest form of radiation.
There we go. And there's one more.
Oh wait, I'm trying to read my list.
You're good.
A helium particle or
Yep.
helium nucleus.
So see how it says 4-2 helium? That is
Yeah.
the nucleus, no electrons. Here we have 4-2 helium. Okay, a helium nucleus. Okay, so perfect. Love it. Gonna go to the next person. Thank you, Charles. Faisal, what did you do for beta particle?
Yes, ma'am. So for beta particle, the first thing that I put is the symbol, so the 0, -1b.
0, -1e, right? This is, so what is that a symbol for? What subatomic particle?
The beta particles.
Right, so beta particle, see the letter E, what does that stand for? What do you think?
The electrons, right?
Yeah, they are another thing for electrons. So fun fact, beta particles are electrons with no atom. It's like calling a kid an orphan. It's still a kid, but it's just by itself, right? So beta particles are orphan electrons, okay? Which I know is a super morbid, sad analogy, but ... it's the truth. So electrons that don't have any parent nucleus, right, are beta particles. So the electron is when it's attached to the nucleus. The beta particle is when it's alone. Perfect. Keep going. Sorry, didn't mean to interrupt.
Did you want me to give another one?
Give me one more.
Okay. Faster. Okay. Gamma ray can be stopped. I think this one can be stopped by aluminum. Yes.
Yes, it can be stopped by aluminum. Good job. All right. And I'm also going to give you the fact that it's called beta and it's a negative charge because it's an electron. So it's the beta negative. That's the Greek letter beta. Okay. Thank you. Let's go to Celine. So if a beta particle is a negative electron, what is a positron? I've never heard that before. Hypothetically, I have. Spoiler alert.
The positive version of it?
Yes, it's a positive electron. It's like the electron went to Stranger Things and into the upside down and doing everything we don't expect, right? So a positron is a backwards electron. It is actually an electron with a positive charge. And we're not going to talk about why right now. If you go to AP and IB, we will talk about why. But for right now, let's press the I believe button and say Miss Longley told me so. And know that a positron is like a backwards electron. It is what we call an antimatter electron, okay? And it is a positive charge, okay? So it's the same symbol, but notice it's a positive on the bottom instead of a negative. They are just inverses of one another.
So is the positron like, because I know that electrons have like basically no weight at all. So positrons, they also have no weight, but they're just positive.
Yes, it's a positive electron, which shouldn't happen necessarily, but it does. And there's a lot of quantum reasons why, and why the quantum, part of the reason why the quantum model of the atom came into existence. But like I said, that's a very APIB, that's like a whole class on why electrons are electrons and positrons are positrons. So we're just gonna press the I believe button right now. But if you want to talk about that more, either hit me up in an email and I can send you some stuff, or come to tutoring and I'll chat with you guys just for fun, okay? So positrons are antimatter electrons. So we have electrons and anti-electrons, right? So they have a similar symbol. It's beta plus. So positrons are beta plus, okay? And if this one can be stopped by aluminum, and you hit the nail on the head, so I'm gonna have you speak again. When you said, is it just like the same, it's like negligible mass, is it the same size? If it's the same size, what can it also be stopped by? So if beta particles can be stopped by aluminum, oh, I'm sorry, I forgot to click the wheel. Izzy. Are you there, Isabella?
Hi. Sorry, it was being weird.
You're good. So it can be, so if this one's stopped by aluminum, what do you think about this one?
Can also be stopped by aluminum.
Right. So why is that the case, do you think?
They're the same size and they kind of move the same.
They're the same size. Yes, exactly. So its ability to penetrate something, like remember how we talked with gold foil, how it's mostly space and the alpha particles were able to move between the nuclei, right? So, and by the way, gold foil was alpha particles, so making that connection. It's about the size. So it's like soccer balls and soccer nets. A soccer net will stop a soccer ball. Doesn't matter if the soccer ball is pink, green, yellow, rainbow, white, doesn't matter. The size of the soccer ball, considering that it's a standard size soccer ball, doesn't change. The size of the net doesn't change. Therefore, it's still filtered no matter what its other characteristics are. So even though it's positive or negative, it's still stopped because the aluminum sheet is really a filter with spaces like a coffee filter. Does that make sense? Because atoms are not solid. We're tracking all of the things. We're kind of circling back on some concepts here, okay? That means a gamma ray is 0, 0. It has no mass, no charge. It is pure energy, and that's the Greek letter gamma. It is electromagnetic radiation, just like what comes off the sun. And it is the most damaging because it has no filter that can stop it. It doesn't have mass, so it goes through everything. It just tears stuff up, like, right? So scale of 1 to 10 on sorting particles. How are we feeling? Okay. So continuing on, changing gears here, we have fission and fusion. So these are type of nuclear reactions that happen, and they result in those types of particles being used, either captured or combined or ejected or emitted. Okay, so we're going to talk about that in a second, but these are types of reactions. So fun fact, oh, I hate the bell in the middle of class, so annoying. Eden, if you had to describe fission in your own words, how would you describe it?
It's like, well, I'll say that one like it turns into two, I guess. Like,
yes, that's perfect, right? One larger atom breaks into 2 or more smaller ones. So a big atom breaks apart. It looks like this. We have a big old atom. We hit it with like a neutron or something. It gets hit by a tiny little thing and just explodes. It's not really that stable. The great analogy is when you're feeling really upset and someone does just the right thing and you like explode at them with energy and you're not sure why. You're like, oh my God, stop chewing that loud. Or, you know, like something that shouldn't be that big of a deal, and you kind of freak out and everything falls apart. That's kind of what fission is, right? So we're a basically unstable atom that's getting hit with the neutron, decreasing our stability, and we're splitting into 2. Okay, this is what happens in nuclear reactors on like Navy ships and power plants. It's mostly what happens in our man-made universe. Okay, fusion is what happens on the sun and has much more energy in it. Okay, so Eden, you did a great job describing fission. So I'm going to have Trisha describe fusion.
It's when 2 like join to make a larger one.
Beautiful. 2 or more lighter atoms make a larger one. So the atomic number goes up. Okay, the atomic number goes up. Hold on, I'm gonna shut the door. Give me 1 second, 'cause I know it's not. Everyone's releasing for lunch. It's very loud. Thank you. All right, so it looks like this. We have two smaller things coming together to form one bigger thing. Beautiful. All right, so we're going to categorize these, and I'm going to do these pretty fast. We're going to go through. So, Sangeet, what's in nuclear power plants? What did I say?
Was it fission?
It was, let me change the color of this so I can actually see. It was fission. We are taking uranium, shooting it with neutrons and splitting it apart and releasing energy. Okay, so that's what uranium does. Uranium is unstable. All we have to do is hit it with some neutrons and then boom, cascade of reactions, energy everywhere. Everybody has electricity and you can attend Zoom class. It's so great how all that happens. It's fantastic. All right, next. Has more energy released than in a chemical reaction? Akshar. Fission, fusion, or both?
Is it fission?
So fission does have more energy than in a normal chemical reaction, which is why we have to have whole buildings and lead walls and things to hold it in. There are also things like the sun that do fusion. So do you think the sun has more energy than the normal chemical reaction that happens in your lab?
Yeah.
Yeah, so both of them release obscene amounts of energy. So this one's actually going to be both, okay? They both release more energy than in a chemical reaction, okay? Are not going to be worried about exploding if we, make some salt in the lab. All right, Adhish, most power per gram, fission or fusion?
I would say fusion, maybe.
Absolutely, fusion is the powerhouse. It is crazy amounts of energy. All right, next up. A large nucleus splits into smaller nuclei. Evangelina, which one's that?
That's fission.
Fission. And then two atoms combine to make a larger, heavier atom. Milan, what's that?
That's fusion.
That is fusion. Okay, this picture, what is that? Kira.
Isn't that fusion or no fusion?
So we have one big atom. Hello. One big uranium atom. We shoot a neutron at it, and now we have
fission.
Yeah, two smaller atoms, right? So this is fission. And this is what happens in a nuclear power plant, if you want to know. And every time we break apart, we release some more neutrons, which hit more uranium. And that's why we call it like the cascade effect. Like you only have to hit one nuclei, and then all the resulting neutrons hit more and more and more and more. And it's like a domino. Okay, it's why nuclear power plants work. The atomic bomb, SIA, not SIA, SIA. Atomic.
Would that be fusion?
So we do not have a fusion bomb. So the atomic bomb is splitting hydrogen atom, the proton and the hydrogen bomb, right? Yeah, so it's fission, okay? I know that it's hard to, like, if we could get a fusion, if we could harness the power of fusion within like a nuclear plant structure, we could power the entire state of Texas with one plant. Like, it's an obscene amount of energy. I wish we could harness it, but we've made small fusion reactors, tiny little ones, but nothing on a large scale because it's terrifying how much energy it releases. Okay, so we're going to shift our focus to something more chemistry looking versus conceptual. So Maheen, okay, I want you to take a look, and the cue to these ones is looking at the atomic number. We have 13 and 2. And that combines to make 15 and 0, okay? So do you think this is fission or fusion?
Fusion?
It is, because we had two smaller nuclei combine into a bigger one. This one isn't an atom, is it? It's just a neutron being released, kind of like this guy. It's not an actual atom. So the atoms that are present, we had two smaller atoms combined to form a big one. That is fusion. Beautiful. All right. Next, Sneha, what is this one? We have calcium getting hit with a neutron and forming potassium, and hydrogen?
That would be fission.
Fission, what was your cue?
Because it splits into 2.
Yeah, 20 turns into 19 and 1. Beautiful. And last but definitely not least, Jessica.
Yeah.
What is this guy?
It would be fission.
How do you know it's fission?
The 92 splits between the 56 and 36.
Yes, the 92 splits between the 56 and the 36. So we split into 2 things. That is also fission. Scale of 1 to 10 before we move and level up a little bit. We can recognize we're going to move to predicting. So if we can't recognize, we won't be able to predict. I love all the chat things happening. All righty then. Okay. Dun, 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 dun. So now we don't have complete equations. We're going to have to use our brain power to figure out what's missing. Okay, we have to use our brain power to figure out what's missing. So I want you to take a look at this, and I'm going to erase a little bit of it so that way it's not as confusing. Let me erase this part just so I can look at this guy. All right, so if we look at the bottom, we see 13 plus 2 is equal to 15 for our atomic numbers. Here we have 15 plus 0 is equal to 15. Did that number change? No. Why can't that number change, Gus? Why can't that number change?
Hello, can you hear me?
Hello, I can hear you.
That number cannot change because it's the number of protons, which cannot change.
Yes, we have, if we start with protons, we got to end with protons. And when you took the stupid star test, which I never said out loud was stupid, I'll never admit it out loud. But when you took the stupid star test in 8th grade and they told you, hey, matter cannot be created nor destroyed, it was a law. Does anyone remember the name of that law?
The law of conservation of, I actually don't know.
No, dude, you are tracking. Don't do that. No, be confident. Law of conservation of mass or matter. It's the same thing. So all that means is that everything that existed before a reaction has to exist after. So all the numbers have to match on both sides or you didn't do something right because it can't physically exist that way. So if you look at the top, the same thing happened, right? 27 plus 4 was equal to 31 for a mass because that's the mass number. 30 plus 1 was equal to 31. So with that in mind, knowing that the mass cannot change, Sonali, okay, how do I fill in this blank? What do you think I could do?
You could put a -1, so it would subtract 1.
Oh yeah, you're talking about the bottom, right? Yeah, so we know that 89, picture this arrow as an equal sign, okay? Just make an equal sign in your head. 89 equals 90 plus blank. Okay, so how do we get this? Is -1. That means a -1 is on the bottom. I love that. I love that you tackled the hard thing first. That is the moonshot factory lived out, my friend. Eva, how would you do the top?
Don't you just subtract them?
Yeah, so I would subtract. So I have my equal sign, right? I want to find out how many more I need. So in this case, I have 227 equals 227 plus something. So what does this number have to be?
0.
And which particle did we have that had 0 and -1 since you're already on the line, Eva?
The beta.
The beta particle, which has, if we had the 0, so there was this notation, but what was the other notation that had 0 and -1 in it?
Electron.
Yes, yes. So here, okay, we have the electron. It's also a beta particle. Why do we know we can call it a beta particle? Let me call in someone else. Carter, why do I know this is called a beta particle right now? When is it an electron and when is it a beta particle?
When it's positive or negative, I mean.
It's negative, right? But a beta particle is an electron, whether there's one condition. So there's a condition in which we call it a beta particle, and there's a condition in which we call it an electron, but we're describing the same exact thing. Like the same exact electron could be an electron or a beta particle, depending on this one thing. Do you remember what I said it was?
No.
If you don't, that's okay. Someone else. What was the terrible analogy I used?
Orphans?
Yeah, it's an orphan electron. It has no atom. It was ejected from the atom. It doesn't have a home, right? So electrons that are ejected into the universe are orphan electrons. We call them beta particles. So to tell whether this is leaving or coming, okay, we started with one thing and we ended with two things, which mean it came together and combined, or did it break apart? Magana, did that combine or break apart? We have one thing turning into two things.
It broke apart.
It broke apart. The fancy word in science for break apart, okay, is emission. So the fun way to remember emission is like Elsa and we let it go, okay? Emission is like Elsa, let it go, let it go. I can't sing, but I will. So emission is like Elsa, we let it go, right? And we let go what particle? What is it called because it's an orphan? Anybody? Anybody?
The beta particle.
It's a beta emission, right? Because it's a beta particle. Okay. Love it. Scale of 1 to 10. Okay. I see. So what I'm seeing in the chat is either we have very high numbers or very low numbers. So fun fact, these three are what we're going to be doing for the day. But I have a whole nother slide here if anyone wants to stay after and get some tutoring on this because they're still completely lost, because that has been a common theme because this is really weird. Okay, so if you are struggling, that's okay. I already have pre-built tutoring time built in because I love you. Okay, so next question. All right, Wajihah, can you tell me what is different about this mercury atom and how I fix it? What is
it doesn't like have a space for protons up near the
it
bottom.
doesn't tell me the number of protons. How do I fix that?
Look on the periodic table.
Yeah, periodic table. So if I go behind me and I look at the periodic table, I see that mercury is atomic number 80. Okay, so that's an 80. All right, thank you so much for elucidating that for me, Kai. All right, so the number on the top, remember this is our equal sign. So I have 201 plus 0. What does that equal?
201.
Yes, so that is the number on the top. So here's the tricky question. I have 80 plus -1. What number is on the bottom?
79.
Beautiful. You handled that perfectly. So I want you to try saying it again with more confidence.
Okay, 79.
Yes. See, I love that question. I know it's silly, but there's so much science and research behind self-talk, and the way that you talk to yourself affects literally your performance. Like when you stand in a superhero pose or when you talk to yourself in a positive way, you score significantly higher on assessments than if you are doubting yourself. So positive self-talk and confidence, this is why I'm so big on it. And I hope you guys have noticed that it is a big deal in my life, and I hope it's a big deal in your life to talk to yourself nicely. Okay, Darshan, can you help me figure out which element this is?
79. That is, here we go. Gold.
It is gold, AU, it is gold. Goldfinger would be so happy we finally made gold, right? All of alchemy, it worked. So nuclear reaction, we have gold left over. So now the harder part of the question, okay? Renee, you ready to go on an adventure with me?
Yeah.
How do we name this? Okay, so first off, are we breaking apart or losing something, or are we gaining something?
You're gaining.
How do you know we're gaining?
Well, you're adding the electron.
Yeah, so it's on the left side, right? So this is like a moment in time. This is over time. So we had two things, and now we have one thing. So they combined, okay? In chemistry, in nuclear reactions, remember what we called combining something?
Fusion.
So fusion, yes, this is a type of fusion reaction, but when we're talking about specifically the particle we added, there's a way we say it, okay? We call it capturing, okay? Capture, like kidnapping. Like we're literally holding it hostage. It is Hotel California up in this atom. You can come anytime you like, but you can never leave, right? We have captured you. We have captured you. So what did we capture? This is the hard part. What did we capture?
The electron.
Oh my goodness, you did it. Oh my God, I love it. Okay, so every other person has said beta, okay, because we just said beta up here. Why is it electron and not beta?
Because it's not an orphan.
It's not an orphan. Oh my God, that was so beautiful. I didn't even pay you. God, that was free. That's amazing. Okay. That was the first time that's happened in all of the class periods, and I'm so excited right now. Okay. So yes, we are adding it to the atom, and it is not an orphan. It is attached to something, so it is an electron. When it's an orphan and being ejected, that's when it's a beta particle. Okay. So we have an electron capture. Fun side note, I know I'm only showing you electron and beta right here because that is the hardest one to identify. But you can also eject or emit or capture alpha particles, gamma radiation, all of those. But knowing these two is the hardest part, and that's where on the multiple choice portion of the test, if they ask you to identify, never say electron emission. EE don't go together. It's not electron emission. The only other word we use instead of emission is you may see the word decay, because it's breaking apart, like decomposition. So emission or decay are the same thing. You will never see electron emission together. That's not how they go, okay? Because some dead white guy decided that made sense, but we're doing it now. Yes, it is not an orphan. Sorry, someone asked me to, respect your privacy. May you explain again why it is not an orphan? Absolutely. We're taking two things and we are combining it into one. So where is that electron now? That electron is now inside the atom. So we captured what is now our electron. Here we had an electron and we let it go into the universe on its own with no parent. That is an orphan, and that is why it's a beta. Does that help the person that asked the text in the chat? Want to maintain your privacy if that's how you felt. Perfect. All right, last one I want you to try on your own, and I'm going to call on someone and ask what you did. All right. Let's see who the wheel has chosen. Saya, how do I start?
I've been trying to figure out what's going on as you've been doing it, but I have no idea.
All right, so first, what do we do here? We have to know the entire isotope notation. So what is this bottom number? Where do I find that? What is that? You remember from the isotope lesson?
Protons?
So that's the number of protons, exactly, which is also called our atomic number. Where do I find that?
Periodic table.
So we find that on the periodic table, and you can use ptable.com or a periodic table from your reference book. So when you look it up, potassium's periodic table block, right, has the K, it has a number down here, and has the number 19, okay? So we have 19 here, okay? So if you don't mind, since you're lost, do you mind if I tutor you for the group so that way everyone else who is lost can also get that information? Will you go on this?
Of course, go ahead.
Love that. Okay. I know it's nerve-wracking when you're like, I'm gonna be vulnerable in front of everybody. And I'm like, yes, vulnerability is awesome. Brene Brown. Live it, love it. Okay, so 19. Remember I said you can turn this into what mathematical operator? Do you remember?
No.
So picture that like an equal sign, because everything on this side has to equal everything on this side, including the bottom number we are trying to find out. Does that make sense?
Yeah.
So we have 19 equals -1 plus something. So what minus 1 is equal to 19?
20.
20. So that means our bottom number, which you said was a number of protons, is 20. So which element is that? How do I find out?
You would go on the periodic table again.
Yeah, I would look and see 20, and I'd have a number. And what symbol is that?
Can I check?
Absolutely. Please check. I love that. Yes, find out for yourself.
Calcium?
It is calcium. Lovely. So that is what we're writing here is calcium. How do I find this top number? If this is an equal sign, how do you think I find the top number?
It's the 42, and then it's like, I don't know how to say it, but
okay, so we have
the top number be 42.
Yeah, 42 equals 0 plus something. So what is it? Yep. So what is this?
42.
Yep. And you did it. Okay, that is how you set it up. So I'm going to erase this one box so it's less confusing, so we can see it all together. 42, 20 calcium. All right, now the hardest part, Saya, we have to name it. Okay, so do we have one thing turning into two things, or two things combining into one thing?
One thing turning into two things.
So is that emission or capture when we have one thing breaking apart into two things?
Emission?
Yes, emission. We're letting it go. We're letting one part of ourself go. So we have become smaller, and we let a smaller thing break off as well. We're letting something go, breaking apart, breaking off, emission. Love it. Now, we see that the letter E is there, so we know it's a version of an electron. So the question is, if we're breaking off and letting it go, is it an orphan electron or an adopted electron?
I don't know.
Okay, so pretend you have a peanut butter jelly sandwich, okay? And you cut it in half and then give half of it away, okay?
Why would I do that?
Why? I don't know. I don't understand. It was the first thing I thought of, and I would never do that. I actually have 2 peanut butter and jellies for lunch today. I kid you not. Like, that is a real thing I'm eating for lunch with bananas in it. I'm so excited. Do like the banana and the peanut butter and the, oh, it's gonna be so good. But I know it's like with toasted bread. Oh, it's my favorite. Anyway, so I don't know why you'd split it up, but let's pretend that someone is cray-cray and needs to be institutionalized, and they cut their sandwich in half and gave it away, okay? Do you still have that other half of the sandwich? Is it by itself, or is it something that you have?
It's something that, yeah, you still have the other half.
You have one half, but what did you do to the other half?
You gave it away.
Okay, so picture this like breaking things apart. I still have my calcium, right? Because that is a bigger atom. It's going to stay. But what happens to this electron? I am giving it away to the universe, so it is alone. Okay, it is no longer in my atom, so it is an orphan. It has no nucleus to be its mom and dad. Okay, it has no nucleus. It has no parents. So an electron that was released into the universe because it broke off of our potassium, and it's why we now have a calcium. We broke off an electron, things happened, words were said, we can't fix it, okay, going to the lawyer, we're breaking up, okay? While we don't have that electron anymore, okay, that is when it's an orphan. So an orphan electron was called the beta particle. So that is beta emission. You could also say beta decay, and I would accept that as well. Does that make sense?
Yeah, that makes sense. I think it's because I didn't get to the last half of the notes. I fell asleep on my chair.
Oh no! You know, I've done that grading. Like when I was trying to catch up on all y'all's grades, I was like, I was gonna have this done by Friday, and there was like one class period. I fell asleep. I'm like, this is now a Saturday morning thing. Night night.
Pretty comfortable too. It's not like it was bad.
Good. Yeah, I have a very comfy chair too. That's the problem. I have one of those like Papazon circle chairs, and I was all curled up with my phone grading. It was awful. I set myself up for failure, but it was wonderful because the sleep felt great. So if we look here, I'm not going to stay and do these with everybody. If you would like to stay and see another example, you're free to. But before you hang up, okay, couple things. One, emission and decay are the same thing, Sangeet. That's what I'm saying. They are synonyms. Emission and decay are synonyms. Does that make sense? I just realized you asked me that privately and I said your name. I apologize. Yes, emission and decay are synonyms. They're the same thing. Couple things. One, you have your test Friday, so do your pretest. It has unlimited attempts. Do it as many times as you can. And I know you have other classes to do. I'm not cognizant of that, but do it as many times as you can before the test and you will do much better. Two, in Canvas, your due dates are both in the titles and on the weekly learning plan. So even if Canvas glitches and doesn't show everything in your calendar, because I had someone send me a screenshot where it showed and didn't show at one point, but yes, use the due date headers to know when things are due, okay? You will be able to use ptable.com and desmos.com as a calculator during your exam. Your exam is open note, open book, all of that stuff. The only thing we ask that you don't text your friends, but I took you through last time the logic of why that's actually the least fast option. Yes, I have another question about electron and beta, like when to use electron, when to use beta. So what I'm going to do is I'm going to let everybody else go. And if you want to hear electron versus beta again, or if you want to see one of these problems, go ahead and stay. But I don't want to make everybody stay if you're good. All right. I will see you in 48 hours. Give me a second, let people hang up. Because it beeps a lot. Okay. So electron emission. So when we, in the top here, we use the word beta when it's by itself. Beta is by itself, okay? It's an orphan, it's alone. When we have electron, it's attached to an atom. So I know that's a lot of writing, so I will do something here to show you. Ignore the problems, okay? So if I have, where's my thing? Anything, okay, plus an electron yields something else. We are combining this electron into our atom. We are combining to form one thing. This electron used to be alone and now has a parent. That is when we call it electron. And when we combine, it's called capture, okay? If we have anything and it breaks apart into an electron plus something else. So we are losing this electron to the universe. It is going away, right? We are breaking apart. We are splitting forever. This electron used to have a parent, but now does not. That is when we call it beta, or you can always use that symbol, right? Sorry. You can always use this symbol, okay? But we call it beta emission or beta decay because it is by itself in the universe, okay? Beta decay, beta emission, they're the same thing. Does that make more sense? Explaining it again, was that helpful?
So when the electron's on the reactant side, then it's an electron capture, and then if it's on the right side, it's the beta emission.
Yes, if it's produced, it's emitted. If it's reacting, it's gained. Yes.
Okay.
So during both of these processes, are the do the number of protons change, right? Like if there's one electron gained, then does like one proton leave or something like that?
Basically, because it's the same neutral charge, so you know that both had to happen at the same time, right? Because if it remains a neutral molecule and it doesn't change its charge, then that means that something's being lost at the same time it's being gained. We only represent the one because that was the major change that forced the other one to happen. Does that make sense? So yes, you deduced what we were not saying.
Okay.
Good for you, science brain. Big brain moment right there. Loved it. Good for you.
Thank you.
All right. Does anyone want to see me do another one? Is that why a lot of you stayed? What are you guys wanting to see? We're running this.
I think I just want to see like you doing it and then like figuring out what it is, like electron
Capture. And remember, it can be any particle it's emitted or captured, but I wanted to make sure, I saw that, Izzy. I wanted to make sure that you guys knew the difference because it's very difficult. Ooh, why did that happen? Hold on. Erase the link on slide. Okay, so for this guy, we have, I'm actually gonna do this one because I have all their numbers memorized. Okay, so I have 19 and I have 18. These are from the periodic table. Potassium is atomic number 19. Argon is number 18 here on the table. Okay, so I have 37 is equal to blank plus 37, and I have 19 is equal to blank plus 18. So I know that this one has to be 0 and this one has to be 1. So that's a positive 1, okay, 0, 1. What could have happened here? Anybody? Anybody? It was 0, positive 1. What was that? Do you guys remember? In your notes, we did it in the card sort. What was 0, positive 1?
Isn't that positron? I don't know how to
Positron. Yes, it was. Good for you. See, confidence. Okay, positron, positron. So if I have the positron, that's an E. Okay, so we have 3719 positron, argon. So is this being emitted or captured, Esty?
Most definitely captured.
So most definitely it would be captured if it was on this side. The reason it looks like it's captured and what mentally happens, and this has happened with almost everyone that's stayed after for tutoring, they see a plus sign and think capture, right? That is not the case. What we're saying is and, okay? Not plus, not combining. We have one thing, now we have this and this, okay? That's like I had an Oreo, now I have 2 halves of the Oreo. Half with cream, half without cream, or whatever, right? We're splitting it apart into 2 separate things. So instead of seeing plus, think and. I start off with this, and it became that and that, okay? It helps with the mental game of knowing that plus isn't capture. And I love that you said that because I've literally had to repeat that like so many times, and you are not the only one, so I guarantee you someone else has stayed thought the same thing, okay? And. So if we are breaking apart into 2 things, that is emission, okay? So if we have one item and it breaks up into 2 items, this is emission because we are breaking apart, okay? We broke apart into 2. If I have 2 things and I'm combining into 1 thing, that is capture, okay? So this and this forms that. That forms that and that. So that's the idea, okay? So we know it's emission, and you said the word correctly that it is a positron emission because that is what that is called, okay? Let's do another one. I'm gonna clear the slide. Dun, 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 dun. All right, so now let's do this guy. So again, we have 19 and we have 18, but notice the top is slightly different. And now where we had the plus sign on the right, we now have the plus sign on the left. So before even doing a single number, do we have this as emission or capture, Esty?
That would be capture.
Yes, this is capture. We don't even have to do the problem to know it's capture because we have 2 things turning into 1 thing. Okay, perfect. Love that. The other way that a student told me they think about it, because they're very English and writing oriented, is they pictured every plus sign as a comma. So it's like listing things instead of combining them. Does that make sense? So if that helps you, thinking of it as a comma or an and or an ampersand or whatever helps you, okay? So we have 19 plus blank equals 18. So what does this have to be?
-1.
Yep, so we have -1, -1. And the top has 40 plus blank equals 40. So what does this have to be?
0.
Yep, so we have 0, -1, which is an electron. So do we use the word beta or the word electron? Anybody?
Beta.
Say again? So,
Beta.
so beta is when it's alone. So if this electron now is combined into one thing, is that electron inside something else or is it by itself?
It's inside.
If it's inside, it's an electron. Remember that electron and emission can never go together because it's not called an electron when it's alone, okay? Electron cannot equal emission, okay? Electron cannot equal emission. So all why did I do that? All captures are electrons, okay? All captures are electrons. See, I had more examples if you guys needed help. So, eraser, erase that, because I don't know why I did that. Does that make sense? So electron is with capture, beta is with emission. Okay, break it off, let it go, Elsa, emission. Okay, and beta because it's an orphan because we emitted it and we let it go. If we had to let it go, it has to be on its own. Therefore, it's an orphan electron and it's a beta. Okay, any other questions? Does that help? Beta is always going to be emission, yes. Emission decay is fission and capture is fusion. Yes, it is. Good catch. Good catch. Okay. If that is it, I will let you guys go. Thank you for hanging out and getting more help. I know that the test is coming and that is nerve-wracking. So if you need more help by tomorrow, I have tutoring tomorrow. Okay?
Thank you.
I'm still a little confused with whenever you talk about the orphan.
Sure. Let me draw a picture for you. I want to make sure you get it. And I appreciate that you are willing to stay and try to get it. The grit you're showing right now is really good because it'd be really easy to be like, whatever, she said it like 10,000 times, I'm done, right? So pretend we have an atom, okay? I'm just going to go like this and pretend that's a lot of protons and neutrons, right? And let's say we have a little tiny electron, okay? I'm putting that for the negative sign, okay? When we combine these into something new, it is now just an atom with another electron on it. They're together, right? So since they ended up together, it was captured by this nucleus. This nucleus captured or gained that electron. That is called a capture. And we name it electron because it has a mom now, okay? If you have an atom and it breaks apart into another atom plus an electron, right? Now this electron has left. That electron was right here and it left and went away. Hence the orphan phrase or emission. It was ejected off the nucleus. It is now alone. That is when it's emitted. So we had an electron inside of an atom and we broke it off. That is when it's emitted. Does that make more sense with the pictures?
Yes, it does. Yeah. Thank you.
No problem.
Thank you. Bye.
Bye, guys. So, okay, she's gone.